The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we've initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is continuous integration in an enterprise data warehouse setup. We expect the webinar to last for about an hour with 45 minutes of presentation and the remainder time for question and answer round. If you have any questions, please submit them using questions tab in your control panel. Our guest speaker today is Sangeeta Rajgopalan, QE Manager, Data Technology at PayPal. Sangeeta has 14 years experience in the world of quality assurance. She has been working on building automation solutions, end-to-end testing capabilities, and implementing continuous integration solutions for the web-based applications and currently in enterprise data warehouse. Sangeeta is currently working as a QE manager at PayPal Data Technology team, and her team focuses on building automation framework and continuous integration solutions for the various development work handled by engineering teams in this organization. She's managed the testing effort across various other organizations in PayPal and also the regression testing efforts within PayPal. Prior to joining PayPal, she worked for consulting organizations like CSC, CTS, other than quality assurance, other areas of expertise include program management, software project management, process improvement, and vendor management. She holds a master's in computer application, and she lives in Chennai with her husband and 2 kids and loves music. So without further delay, I introduce you all to our guest speaker today. Over to you, Sangeeta.
Thank you, Deepika, for the introduction, and thank you one and all for taking time to attend this webinar. I would also like to thank TechGig for providing me with this opportunity. Today's topic, continuous integration in an enterprise data warehouse setup. So continuous integration, as you all know, is an engineering practice, and it is widely used in the world of application development. Maybe you should be familiar with languages like C++, Java, etc. But then when it came to the world of data warehousing, it was not very common. The same was the case for us as well in our organization. Continuous integration was widely practiced in our product development organizations, but this was not something that was meant to be possible in the data world. In today's webinar, you'll hear more about our continuous integration journey in the data world. So some of the high-level areas that I'll be covering today as part of this webinar are as follows. A brief on what are the typical EDW flows in our data technology teams, some of the challenges that we had to deal with as part of our EDW testing, and what was our approach towards continuous integration, and also talk a little about the challenges what we faced in institutionalizing this continuous integration. We'll also have some time towards the end of it for question and answers. So as you can see in the slide, this is a typical EDW architecture. So a data warehouse is a concept of data being extracted from heterogeneous operational systems and is made available as historical snapshots for ad hoc queries or also for scheduled reporting. So basically data from different source systems are processed via ETL, or known as extract, transform and load. So once it is extracted, transformed, it's loaded back onto data warehousing tables and then onto data marts. To talk a little more about testing, testing primarily happens in the ETL phase. So the Informatica loading process or the BTEX are primarily tested, and in general the situation is like we do not have much visibility onto how some of these tests are being handled, either during development cycle or exactly when is it that normally it's taking place. Say for example, if I I'm doing a data transformation from source to destination. Is that being tested or validated accurately? Do we have the expected data that's added back onto the targeted system? Are all the DB fields or field data loaded without any truncation? Do we have enough validation for all the null value fields? So, etc. These are a few examples, and most of the times we did not quite surely know that these have been handled appropriately. And not just about testing, most of these were primarily manually tested, and then we just had few tools that was available for performing these tests in an automated fashion. So towards the start of 2014, this is pretty much how even our testing cycle looked like. So most of the times the testing started towards the late of the sprint cycle, because we were in an agile development mode and we were working on sprint cycles. It's pretty much towards the late or end of the sprint that time was allocated for testing. And then there were very minimal automated tests available. So engineer had to spend time manually to run all of the tests that were required. And some of the times, due to lack of time constraint, it was not possible to have an elaborate testing done, and it was not quite sure if all of the testing were being done effectively. And then there were very minimal automated tests available to support faster testing cycles as well. So since most of the time was spent on manually testing it, the time consumption was really high, and this was not something that could have been affordable in an agile cycle. With testing coming in late in the cycle, the other possible problem was to identify defects or bugs towards the end of the development cycle. So when you identify towards the end of the development cycle, there's again a lot of churn, and there's a increased cost in getting these fixed towards the end of the cycle. But last but not the least, if you're asking about what is the confidence of the code quality that is being delivered, it was not something that was great. So in a nutshell, there was testing that was happening, but are you confident about what is being tested, and is it quite good amount of testing that's been spent across towards the sprint cycle? Most of these were like vaguely answered, or this is not something that people were comfortable with. So this is when we decided that how is it that we'll have to move ahead and then change the way the typical testing that normally takes place in our organization. How do we change that? And does continuous integration really play any significant role even in the data world? So challenges were multifold. It was not just about continuous integration journey, but there were also enough challenges that we had to deal with as part of EDW testing. So data was heterogeneous, most of you know that, and they were being validated manually. And then, as I called out, manually performing any testing is something that consumes a lot of time, and this hindered our progress of delivering things faster. And then most of the times there were misses, and bugs or defects were either found in life, or pretty much when the merchants or the people come back to us post going live is when we used to understand that there were some issues that had to be fixed. So this kind of back-end testing is typically something that's manually intensive and possibly supplemented by the use of very little or some semi-automated tools. So we needed to have an entirely different testing approach for our agile data warehousing development. So with that in mind, the question then that arose was, how can we enforce disciplined and efficient engineering practice? So the focus was to see how we can start moving testing up in the cycle, and how do we also enable engineers to test faster. So this is exactly when the thought of implementing continuous integration within the data technology team came forward. So we went ahead and started working on a strategy to build a continuous integration workflow for our engineering teams. So when we talk about continuous integration, the approach is same as in any application development, but we did have a lot of limitations in making use of the tools that's available in the market for the enterprise data warehousing. First and foremost thing was to ensure that we had a single source control in place to maintain our source code. This is the same case as in any continuous integration practice. So we need to have a single source of truth against engineering teams maintaining their own local copy of code. So without this in place, it's literally not possible to move ahead with any further steps that was required to ensure that all the engineers or the teams across the board will have access to a single source of truth. So first was to set up that, meaning the version control system, to have a single source of truth. So with that in place, then the focus will be to figure out how can we ensure that we have a mechanism in place to automatically create a build with those changes and perform automated test cases to certify the code. So basically, there's a version control in place, and engineers are now having the flexibility of writing a new code and then checking in. But how do we take that and then start performing automated test? So this is a critical step for continuous integration, and also for us to ensure that the quality is moved upstream. So unless and until we have an automated way of testing the code, it's impossible for enabling the engineers to test faster and also frequently. So with that in mind, we started exploring tools like Jenkins, and we built in an automated build process system. But with that in place, it was quite difficult to come up with tools that were available in the market to automatically perform the automated test that was required for our system in place. So we did not have many tools that were readily available to help us here. So, so the only option was to figure out if we can come up with our own framework and then plug that back into our continuous integration workflow. And that's something that we actually built. So we have a version control system in place. We also have an automated framework that enables the engineers to perform the test in an automated fashion. So once we have this, what is the next step, right? So once these are in place, it was to ensure that the checks are verified and we have a quality code that gets pushed in. So we in fact brought in another step where we came up with a pre-live environment that is quite similar or a mimic to the live environment, where the release engineering team would kind of pull in all the changes, run the deployed codes, validate it against few minor tests, and then see that all of these changes are ready to go live. So with all these checks and verification complete, the code was automatically deployed. So on a high level, I have just given you a vision of how a CI strategy looks. And moving forward in the further slides, we can talk in detail about how this rolled out. So as you can see in this slide, this typically gives you an understanding of what was our approach and a high-level overview of how we implemented continuous integration within our organization. So basically, any developer could perform or develop his code on any of his environments, and once the code is developed, it's ready to be checked in. And the reason you check in is because you have to have a single source of truth. So once you check in, then it's upon the tool to ensure that it automatically picks the changes and then creates a build out of it. So when I talk about build, it's nothing but capturing the changes that the developers have made, primarily files in the world of enterprise data warehousing, pull it, package them, and then kind of make it ready to be deployable in any kind of an environment. So this is pretty much is what that you see in the tab in here. When I say that code is checked in, then the next step for any developer is to ensure that he creates a build-in. So we made use of GitHub, which is the open source tool in here, and I will go in detail about the various tools and the technical approach in the upcoming slide. But on a high level, once the build is ready, the next step that normally goes in is to ensure that this gets deployed onto an environment where the tests can be performed. So we deploy it and then the tests are performed, and we do have different tests that gets invoked depending on the kind of code that is being delivered. So primarily we deal with both ETL and also some of the Hadoop code, and that's the reason you see here two different test engines that gets invoked as part of our internal framework that we have created, and then the tests are run. So once the tests are run, a test report is displayed, and the engineer, or it's available for anybody to view the results of the current test report, and he can have a detailed understanding of how many have failed and passed. So basically this is the entire cycle of our continuous integration flow, and this automatically becomes the audit criteria for release engineering team. So unless and until the tests are passed, it's quite difficult for any team to directly push the code on to live. And this is a gating criteria, and this has definitely helped to ensure that we have the relevant test that needs to be run as part of any code check-in or changes that's happening. And unless and until the test reports were filled, it was not quite possible for any of the code to move live. So with this, we got the advantage of moving the system quality upstream, and then also a confidence in which we were able to test earlier and then release a bug-free code. So as I said, the system that we have developed relies on variety of tools and technologies. So Git is something that we have used to maintain our source code, Maven to build, Nexus to manage the software artifacts and dependencies, and UC for Java APIs were remotely launching workflows. Test cases were all XML based, and the test suites that we have created were managed via Perl, Shell, and also JavaScripts. So for reporting, we also had the Java interface that was created, and Hudson for the overall architecture. So this is the step-by-step approach of what we have developed. So as you can see, first is to automatically build the code, and then we run the static analysis and then have the code deployed onto our QA environment. So if I have to call out a little more and then give you some examples of the kind of static analysis that we do, it can also be termed as the sanity checks. This is primarily the tests that were performed against the ETL code without executing the actual code. And the basic idea was to ensure that they are meeting the typical data warehousing coding standards. So primarily once these tests are being run, the next step was to ensure that these gets deployed onto the environment where the actual testing has to happen. So once the deploy happens on the environment that is being specified, and primarily the QA environment, we invoke the unit and the functional test cases, and at times also the regression test cases based on the needs. So unit test standards here mainly focuses on the data transformation, validation, correction, the data quality checks that primarily will have to be taken care of. And functional test that's mentioned here primarily depends on validating the business logic. So it is up to the team to figure out what is the coverage that they will have. So this framework enables them to write any additional test cases that is needed in order to ensure that the testing is, the required testing is being done as part of any sprint or the Scrum cycle. So once we have the code deployed and the necessary tests run with all the test reports being generated and all the errors or bugs being fixed, this is something that the teams or the engineers can get an idea about from the results metrics dashboard. So this is something that I will also show you in detail in the upcoming slide. But the idea was to ensure that we have a centralized dashboard that clearly indicated the kind of tests that were run and report out how many of the tests have passed or failed with the detailed log, so that it's easy for any engineer to understand where is it that their code failed and then have the appropriate fix in place even before they go ahead for the live deployment. So these steps were basically the entry criteria for any of the production deployment that had to happen within our organization to ensure that the production deploys are fairly tested and we have a smooth production run as well. Apart from that, the framework also gave the flexibility to the engineers to ensure that they're able to add in any amount of sanity or unit test cases standards as per their need, and then customize it and then run them as per every team. So it's not the same set of test cases that had to be run across, but it could be customized and it could also be maintained at team level. So this slide pretty much gives you in detail about the various technologies that we have used as part of our development. So the code is basically pushed into the source control system, and as I mentioned earlier, Git is the source control system that we have leveraged. And to give you a little overview on the kind of code that normally gets pushed in as part of our EDW or enterprise data warehousing development world, these could be SQLs, DDLs, Informatica workflows, UC4 schedulers, and also few of the Hadoop related code. Other than that, as I said, Jenkins is an open source tool that's already available and used as part of continuous integration workflows in any of the application development. So it's the same tool that even we have leveraged here as far as data technology is concerned. So Jenkins is used to create the jobs that will enable to create the build. And it also ensures that we have kicking off the necessary test that needs to be run as part of the testing cycle, and the code gets deployed onto the required environment. So again here the code that gets deployed are SQL scripts, UC4 jobs, or Informatica workflows, and they get deployed onto the respective QA environments after the sanity tests are run. So once these two are done, the ETL execution flow will be triggered to completion, and then next comes the automated runs of unit test standards that gets executed on the environment that is specified. So once we have our unit test runs, then it comes the functional on the regression test cases that gets run. And this is handled pretty much in the form of XML, and it gets executed. It's triggered via the Java framework that we have created for the backend. The stored results are published via a Java application, and it's displayed in the form of a dashboard. And it also gives various insights about the metrics and the pass rate. So the detailed log obviously will help any engineer to understand at root level where the issue has occurred, and with this he will be able to go ahead, make the required changes, and then check in the right code back after fixing in all the errors. So here is a quick a quick snapshot of how our Jenkins workflow is invoked. So this is the first and foremost activity that any engineer would be required to do as part of the continuous integration workflow. So an engineer develops the code, he checks in, and the code that is newly developed is available in Git. So once that is in, this is the first piece of flow that an engineer will automatically have to trigger. So the input that he gives in is the branch name as to where the code change is available, and from where you're instructing Jenkins to kind of pick up the changes. And along with that, the information about the environment as to where the code needs to get deployed will have to be made in here. So just to reiterate, here when we talk about code or a build, it's nothing but the files that needs to get pulled in, packaged, and then deployed back onto your QA or the machine where the testing needs to be performed. So with these two as the input, which is the branch and the environment as to where you have to have the testing run, the next thing that the engineer will need to be selecting is about the continuous integration level. So to briefly talk about what is it that I'm meaning here by the level. So within our organization, what we've done is, like, as part of creating this particular workflow, we also set various maturity levels to see how teams are progressing towards adopting continuous integration. So there were many levels with which it actually can figure out at what maturity level a team is. So in simple words, when we say that a team is ready for CI, CI stands in here for continuous integration, CI level 1, it pretty much meant that the team has the capability of putting in all of their code onto the source code system. So basically they have created a Git repository, and all of their source code is sitting in the Git repository. When we talk about level 2, it is the capability of creating a build from this particular source code and then ensuring that it's ready for deploy. Level 3 talked about running the unit test standards, and then level 4 talked about running the functional test. So depending on the kind of development work that a team or an engineer is performing, and depending on the amount of tests that the team will have to be performing as part of the current changes that is being made, here there is a flexibility that's given into the team to figure out what is the level in which they have to run their test. So here in this case you see that it shows level 4. Basically here what happens is that any checked in code will be pulled in from the Git repository. A build will be created. This build will then get deployed onto the environment that is being specified. Once it is deployed onto the environment, the unit test standards that's automated will get kicked off, and if it successfully passes, then the next step is to run the functional test. So in case there's any breakage and there are no steps that's successful, it kind of stops, and then an error is thrown to the engineer to make him aware that there is some issue. Please go ahead and then figure out where the issue is so that you can fix it and then run it back. So if so appropriately as the changes are required, and if the changes are very minimal and it's just about to see that the deploy is happening, he just needs to check on level 2, and then only the necessary test will be performed. So here is a sample continuous integration results dashboard that we developed, and if you look in here towards the top left corner, there's this high level summary that is displayed, and this pretty much details about the kind of tests that are being run as part of the continuous integration workflow. So in this case, in this example, as you see, the sanity tests have been run, or the static analysis have been run. So pretty much it's just running through the entire code and then figuring out that it has actually met the data warehousing standards while writing the code. So once that is done, the next step was to deploy the code onto the QA box, and you see here a success. And then there are some tests performed on the environment readiness. So basically this step is to ensure that once you're deploying the code onto a box, the necessary connections, say to UC4 or the tables, needs to be available for the remaining tests to be performed. So this primarily tests for that readiness, and if it's success, then it goes on to the next step of running the unit test standards and then moves on to the functional test cases. So if all of these are successful and there are no breakages and the entire run is successful, there's a green thumbs up that is shown, and the percentage of test pass. Now here, see here a green thumbs up, so the percentage is 100. And if it is not, it will also show the appropriate percentage here as to how many test cases have passed and how many have failed. Below this panel is where there's a detailed information given against each and every test that's being performed. The first tab talks about sanity test execution, and here is a log link. Clicking on this will give the detailed log of each and every test that is being run, and with the details of where the failure occurred. So is the case here for each and every tab. If I have to give you a few examples of the sanity tests that normally gets run, it's to verify something like timestamp or date column validation or the format checks. Verify dependency condition is set in the UC4 job plans, or verify if the parent job name is mentioned, and something like server name is mentioned. So these are a few examples of the sanity test. That's something that we capture as part of this particular report. And then so once this is done, as I said, it's about the deployment. So the deployment happens on the boxes that you mentioned, and this tab clearly mentions if it is successful or not and what are the components that is getting deployed. Sorry about it, I just pressed in a few clicks fast. So once the deployment is done, the environment is being checked to figure out if the necessary tests can be run. So as you see in various sections, there's a detailed report on the number of tests that's pass or fail, along with the log here link that gives the detailed log. And then comes the duty execution summary and the functional test summary report. Maybe even to give you a few examples of the unit test case standards that's normally getting handled, it's something like the null handling checks, or the audit column checks, or something like the length truncation checks that is primarily being handled in here. So functional test is something that the teams can write on based on the business logics that's available, but prior to these, whatever is available as part of the workflow are readily available as part of the system itself. So, but there are still scope for any team to add on as many test cases that they want and then plug in onto our automation framework. So this is the dashboard that acts in as the exit criteria for any developer to sign off on the code that is being developed. And this becomes the entry criteria for the release engineering team to accept any codes for the live deployment. So this is pretty much how the working cycle happens. So one of the feedback that we have been hearing is about the detailed log that has been helped, and the idea is to ensure that the area where the test cases fail and the errors, corresponding errors are highlighted so that it doesn't take a long time for engineers to spend on going through the logs and then understanding why it has happened. So there's a significant effort that we spent on building up this dashboard to make the lives of engineers easier, and also to ensure that there's a clarity on identifying errors with very minimal time spent on analyzing umpteen number of logs. This is another view of the metrics dashboard. So unlike the previous dashboard screen that you have seen, that talks about, this pretty much talks about every change that has happened or every commit change that happens in Git. But when it comes to the metrics dashboard, this is a very high-level dashboard that gives an overall picture. This could be based on the team, and this could also be summarized based on the vertical, or also based on a couple of DMPs. That's a couple of pushes that happens as part of any team's monthly deliverables. So this is customizable, and basically the idea here is to understand how a team is progressing, to figure out how many of their code changes were pushed and how many errors were found as part of these pushes. This will actually help the teams to understand how they are progressing. Are they in the upward trend, or is there something that they have to invest more on ensuring that the quality is met as part of any development activity. There is also a metric that we show and capture on adherence towards continuous integration. So the idea here is to figure out any push that is done or delivered as part of a team. Are they necessarily going through the continuous integration workflow, or are they skipping that? So this is something that gets measured in here. And it also gives the number of test cases that gets executed, and of the number of test cases executed, how many have been failing. The high-level clarity, if you dig in detail, there is visibility onto the pattern of the number of the kind of test cases that fails, and then we can map them back onto any kind of deliverables and figure out how best can we improve on the quality aspect and work on figuring out the approaches on testing them in a better fashion. So here, as I said, this is an overall metrics report which is used at a team level against the previous report, where it talks in detail about each and every commit change that happens. So till now, I think I pretty much explained as to how we started off our journey, and then what is it that we built as part of a continuous workflow system, and then gave you a quick snapshot of what is the entry for any engineers to invoke our continuous integration workflow, and what are the different metrics or results dashboard that the teams can use to measure or say that their changes have been successfully tested or not. So when we started off our journey in 2014, as I said, we were not quite sure of what are we testing and how are we testing. But today, we pretty much understand that and have better clarity on understanding what is exactly being tested, and in a way that has actually increased the confidence on the quality of code that is being developed. So defects are detected and fixed sooner because we had clear visibility on what's failing and when it's failing. And with the integrated version control system in place, there was no confusion around what is the source code that is being used versus every engineer working on the same piece of single source of truth. So these were the primary or the starting advantages that we saw. Other than that, it also helped to reduce a lot of assumptions because with continuous integration capability in place, it was just a question of kicking off an automated test, and then it gets run automatically, regularly, and gave us a clear indication of what is the quality of the code. So with this system, it was easy to take decisions, and then it was giving us in-time information about the code that is being developed. So you developed, and immediately you try to understand the health of the code, and that is some data that is available readily for a person to understand if it's in the right direction or there are umpteen number of changes that needs to be made in as part of the development activity. And to some extent, the health of the code that is being developed was measurable because we knew that we knew the number of tests that were being run, the kind of tests that were being run. So this was in control, and it was always possible to add on and figure out where the coverage is less and then work towards increasing the quality coverage. So this has worked pretty well for us and our system. And in each and every step we were able to ensure that the quality aspect is brought in, and we were also able to push quality upstream. So unlike the stages where we were performing tests towards the end of the cycle, this gave us the flexibility of testing as and when a code is being checked in, and then it also gave us an understanding of the health. So in nutshell, this has actually reduced the cycle time by helping the system do that the automated test for us, and thereby increasing the confidence on the deliverables. So overall, I think the continuous integration workflow that has been established with the automated test framework actually has helped us to move quality upstream. But there were also challenges that we had to face as we were institutionalizing this entire workflow. To start with, the primary thing was to see that we had no data warehousing testing tools that was available and that we could make use of for our needs. So there were tools that were available in the market, but that's not something that we could as plug in for our workflow or the system. It needed a lot of customization, and then it either had one feature of just testing the ETL flows but did not have another feature that we needed on maybe deploying the code or working to see if it actually captures all the results and then shows and gives us an indication of whether it's passing or failing. So this was a big challenge as this towards the start of it, and then we had to ensure that we work on we invested a lot of time going through multiple tools, a lot of tools in fact, and then finally we came up to the decision that we have to, if we start building our own automation tool and a framework, probably that will serve our purpose faster, and we would be able to use it the way that we want. And once we settled on the tool and we figured out that these are the technologies and the open source tools that we're going to go ahead and then use, it also required to spend a significant amount of time creating an awareness on why we are doing this, and also hold a lot of training sessions to help the teams and engineers understand the purpose of institutionalizing this. So there was a good amount of time that was invested to ramp the teams up, enable them, and facilitate them towards this transition. So we had to move away from the traditional way of testing. So this is not something that was quite commonly practiced. So in my experience also, it was quite evidently used in the application development scenario, but when it, as I said, when it came to the world of data warehousing, it was like, is it something that's possible or not? So we had to move away from that and then take a risk on working towards building the system and making the teams feel comfortable about using such an workflow and an engineering practice. So this is also something that was challenging, but did work towards the end of it. And last but not the least, there were a lot of environmental challenges, and we had to also deal with a lot of legacy code. So this is not something that was practiced, and when we talk about creating a source code repo, it's about how do we maintain this and what do we do with all the details that were already in system. And since ages this was not handled in a single source code repo, so all of that, and then working on multiple zones. So there are different systems that we had to deal with, and the development happened in various systems. So how do we integrate that? There are ETL testing that had to be handled, Hadoop testing. So how do we integrate all of these, and how do we enable a workflow with such things? So we did not get much of the support from the existing tools, so we had to invest in a lot of time. And finally, we built our own automation framework, and with the available open source tools and the inbuilt automation system, we were able to successfully come up with our continuous integration workflow. So I think with that, I come to the end of my presentation, and I hope it gave you a good insight about it. I'm now open for any questions. So here there is a question from Sushant Mishra, and the question is,
Thank you, Sangeeta.
is there any...
Yeah, thank you, Sangeeta. Thanks for the insightful presentation. I would request you to read the questions and their answers so that all our users may listen to your commendable insights.
Yeah, thank you, Deepika. So here is the first question that I have received, and this is from Sushant Mishra. The question is there any open source automation testing tool for ETL or EDW testing? If yes, what are those? So thanks, Sushant, for this question. So this was one of the challenge that we too had towards the start of 2014. There were not many tools that actually helped us to meet our own requirements, but we are here. There were some tools like so we don't have any kind of open source automation testing tools that I am aware of in the market, and that's one of the primary reasons that we went ahead and developed our own tool. I will go on to the next question. So there are a couple of questions again from Sushant Mishra, and it is about showing interest in the tool that we have shown, and then the question is about how we can use this particular tool. So this is a tool that is quite internal and it's proprietary, so we have not open sourced it yet, but we'll definitely reach out to you if this is happening in the future, so you can keep watching out on this. There is another question where it talks about do we have white box testing for ETL codes or outcome, and this is asked by Balakrishnan. White box testing for ETL codes or outcomes. So it depends on what is it that we are categorizing as white box in here. So today during the presentation I was talking something about the static analysis checks where we were talking about format checks and then something like parent job. So if your question is that, it's like it's up to any engineer to define what is the kind of testing that you have to be doing in, and the way we have categorized it is like static and validation of the standards. So I pretty much am not quite sure if I got the I got to understand this question right, but it's more about if it's about validating the code that is being written, yes, it's up to the engineer to figure out what is the exact validations that you need to do, but you can definitely have different kinds of testing that is that can be performed and against the code that is being written. There is a comment from Sriraj Srikumar, and he has mentioned that we have used an integrated SOAP UI with Jenkins for CI. So I think this is primarily for the web applications or the web server that's happening. So I did not see any question in here, but basically what we do when we integrate SOAP UI with Jenkins, it's primarily done for the web applications. So these are pretty much the questions that I have. I would also wait for some more questions since we also have another 10 minutes to go.
Dear all, if you have any more questions, I would request you to submit them using your questions tab on your control panel.
So there is a question that I have got from Bala Krish, and the question is, do we have error handling methods in ETL to throw critical or minor data quality issues? Yes, we do have. And we do have tools like Informatica that pretty much shows these errors.
Sangeeta, there are a few more questions. Should I read them out?
No, I just got a couple of them.
Sure.
Yeah, so there's a question from Shankara Kumar, and the question is, are you also following continuous deployment for enterprise data warehousing? And what type of tool is that? So continuous deployment is something that is still work in progress. So we are working towards creating this for our enterprise data warehousing development world. So the tool that we're using is pretty much the in-house tool, as I said, but we do have flavors of Jenkins and Git that we are primarily relying on creating a continuous integration workflow. So there is another question from Shushant Mishra. So along with the, here is a question, along with the code level testing, is this CI tool, does the CI tool have the ability to test a database and schema level, irrespective of any database, to validate source and target records? Yes, we do perform these kinds of testing with our tool, and this is primarily handled as part of our unit test standards and functional testing block of it that I just called out as part of the workflow. I've covered all the questions that I have received, Deepika. Okay, so I appreciate all of you taking in time to listen to this webinar. And thank you also for your questions. I hope I have answered them. So
Thank
Deepika,
you
is
so much.
there anything
Thank you so
else?
much, Sangeeta. Thank you for this insightful presentation. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of this webinar will be available on techgig.com shortly. Thank you all.
Thank you.